Hello, Algebra 2 students of ICS. Today we have another lesson. Again, I am Mr. Sutton from Herron High School, and hopefully you all have something to write with and something to write on. If you are able to print off a copy of the notes, it should look something like this. If not, hopefully you have a scratch piece of paper to follow along with. Today's notes, we are continuing our discussion on exponential functions. We are going to be talking more specifically about growth and decay today. So before we discussed how the b value tells us whether it's growth or decay, we talked about how when we have a b value greater than 1, we have growth. And when we have a b value between 0 and 1, we have decay. So we're going to be looking more specifically at some of those examples in today's lesson. So this first example, we have 2 to the x power. We should be pretty familiar with this function by now. This is our parent function. So in order to graph this, I think we should make an XY chart and plug in some values of x, -2, -1, 0, 1, 2, 3, so on. All right, so I'm going to go ahead and pause the video and figure out the y values for these and go ahead and plot those points. Okay, and I want you to do the same along with me. All right, so I went ahead and made my table, and I even went out to 4, 16, because this graph goes up to 20, so we can fit that one in there, 4, 16. So this is what the points look like on the graph. We can go ahead and start making our line, nice smooth curve connecting these points. So on the right, as we start plugging in larger values, it grows really rapidly. As we start plugging in more negative values, it approaches 0. Now, number 2, I'm going to make a U try. I'm going to make this one a U try. So go ahead and try to do the same thing on your own for this one before I give you the table and what the points should look like. Here we have a larger b value. So what we know so far, we should expect this to grow faster. Go ahead and try this one on your own. I'm going to pause the video. Go ahead and try this one now. This is the table and the points that you should have gotten. You'll notice this one goes off the graph much faster. And once we plug in 2, we're already at 18. So our next coordinate is 3, 8, which is way off the graph, and then 4, 162. Before we were able to get up to x equals 4 before we got off the graph, but here we only got up to x equals 2. So I'm going to go ahead and draw in my line. Much steeper curve than what we have previously. But what do we notice about both graphs? Both of these graphs grow rapidly as x approaches infinity. That's what that means there, as x approaches infinity. All right, so here we have 2 examples of growth. This one is a bigger example of growth. Both examples of growth nonetheless. Let's take a look at the next examples here. I'm going to pause the video again. We want to start making a table here for these values. We want to plug in values of x, -2, -1, 0, 1, 2. So I'm going to pause the video, come up with these y values, and plot these coordinates. Okay, do that on your own, please, right now. All right, and these are the values that I came up with. When we plug in the negative values, we get larger, values, and when we plug in positive values, we get smaller. So I actually went ahead and plugged in some more negative values since we have the space here. -3, when you plug that in, you should get 8. And then -4, 1/2 to the -4th power is 16. So kind of the reverse of the example we saw above. So that is what that graph looks like. I want you to go ahead and do a similar thing for number 4. Make a table off to the side and go ahead and plot your points on number 4. I'm going to pause the video and I want you to work on that. Pause the video right now. All right, this is what I came up with. Actually, when I plugged in -3, that's off the graph, so plugging in -2 is probably a better starting point through x equals 2. I used a calculator for all of these, raising 0.4 to these powers and then multiplying that by 2 in 2 steps. So draw in our line like this. And here at the bottom it says, what do you notice about both graphs? So these graphs both decay rapidly as x approaches infinity. So as we start plugging in larger and larger x values, it gets closer and closer to 0. Add that as well. Approaches 0 for both of these cases. So compare equations 1 and 2 with equations 1 and 3. What did you discover? So 1 and 2 have a growth factor that is greater than 1, and they also have a b value that's greater than 1. 3 and 4 have a growth factor that is less than 1. Growth factor that is less than 1. And they also have a b value that's between 0 and 1. We also call this decay. So when you're growing by a fraction, you're actually decaying, right? So let's go ahead and move on to the next part of the notes here, where we officially define these growth and decay terms. So here it says when A is positive, and B is greater than 1, the graph will be increasing, also known as growing. So that's under exponential growth functions. And then next to that, you should see exponential decay functions here. So this is when A is positive and B is between 0 and 1, the graph will be decreasing, decaying. So we're going to look at these graphical examples now. This graph here on the left, we can see is approaching 0 as we plug in larger and larger x values. and it's growing as we plug in negative values. So this is decay. We have a b value that has to be between 0 and 1. Over here, as we plug in larger and larger x values, it grows rapidly. This is growth. Meaning our b value must be greater than 1, right? So we should be able to tell graphically if we have growth or decay. And we should also be able to tell just by looking at our equations without actually making any tables here. So this is our b value right here, 3/2. If you convert that to a decimal, it's 1.5. So that is larger than 1. B is larger than 1. 3/2 is larger than 1. So this is growth. Here we have 1.2 is our b value. 1.2 is larger than 1. So once again, we have growth. And here, 2 is our b value. So 2 is larger than 1. So we have growth here as well. So without actually plugging anything in, making any tables, making any graphs, we can just look at the b value and determine, is this growth or decay? All right. Last thing, I want you to go ahead and do this U-try. I want you to just look at these examples, look at the b values and determine first if f is growth or decay based off of the b value, and then g is growth or decay based off of the b value. Go ahead and pause the video and write down your answers for that right now. And these are the answers you should have gotten. This is the end of the lesson here. So since these are both between 0 and 1, we have decay. Make sure you are taking pictures of your U-tries and submitting them in your forms with your IPs. So don't throw these away as soon as you're done with the lesson. Make sure you're taking pictures of them and submitting those forms on the Haiku page. If you have questions about this lesson, come to my office hours or Parsons or Claywell's office hours. You can find that information on the right-hand side of the Haiku page. I hope you are all staying well, staying healthy, and I hope you are enjoying your extended e-learning period. Have a good day.